Week 8, Part 4 Learning Guide of College Algebra. We've made it. This is the final video for 8 weeks of the Learning Guide for College Algebra. Now, if you haven't been along for this journey, that's okay. Hi, my name's Dr. Marissa May. I'm so excited to help students feel confident in their math classroom, and I'm glad you've joined us. Now, you've missed quite a bit, but I'll link them below. That way you can go back and join all the fun and all the topics that we've been exploring through these 8 weeks of college algebra. Now, if you have been with me, you know that each video focuses only on the topics and the problems on this page of the learning guide. If you want the learning guide, I will definitely link it below. Many people have wanted to print it and follow along as we are working through the problems. I use technology, so I'm going to use Desmos Graphing Calculator. I'll link it below. It's free, it's online, so it's available to everyone. And I love that it helps students feel confident with our topics. So we'll definitely look out for that and put there. Um, Before we wrap up with our last topic, don't forget to connect with me on my social media platforms. I have tons of resources to help teachers and students, like I said, be confident in their math class. So I would love the opportunity to help with you. Follow along for some good information on tips and strategies on how to be successful in your math class. So I hope to see you soon. All right, let's jump in, friends. We are talking about optimization. That's a big fancy word and that's a whole lot of symbols. Let me make it a little bit simpler for you. What we're going to do, friends, is we're going to take a moment and we're going to graph these inequalities in Desmos. We're going to let Desmos do the heavy lifting for us. Let me show you. Now, when I switch our view this time, normally you can see my video. However, today I wanted to maximize the screen and the graph time so that you could see everything that you needed to see. And so I'm not including my picture. I'll include the learning guide because we will write down some things. Let's put these inequalities in here. X is less than or equal to, I'm sorry, I said greater than or equal to, and it should be 0. Then in our next one, let's put Y is greater than or equal to 0. Notice that it's shaded and we've got a darker shading. So this area right here is where the two shadings overlap. That's important to note. Then we put X plus Y is less than or equal to 6. Very nice. Again, we've got 3 shadings and I want you to see the triangle where they overlap. That's important. We've got one more to put in here, and that is X plus Y is greater than or equal to 2. And we've got now 4 shadings, but I want you to see this area right in here where all 4 of them overlap. That's the only area that you're concerned about, where all of the shadings overlap. And Desmos is so nice here to highlight some of those points for us. 0, 2, and 2, 0. And then we've also got this point here, which I believe is 6, 0. And then we've also got this point up here, which is 0, 6. Now, I have used Desmos now for all that I needed to use it for. I'm going to switch our view back because once I let Desmos do all the graphing and the shading, and I get those points where the shading overlaps on the corners, we call those vertices, then I'm done with my graphing because here's what I needed. Here's my X's and here's my Y's. And this is what I need to know. I need to know what is the value of Z. So if X is 0 and Y is 2, then Z would be 8. I'm plugging in 0 for X and 2 for Y. If I do it here, then X would be 2 and Y would be 0. I would get 6. If I do it here, X would be 6 and Y would be 0. And if I do it here, X would be 0 and Y would be 6. Now, what we have to be really careful of is what was the question asking for? The question was asking us to maximize. Okay, that means find the biggest. And that means our biggest value is 24. Where does that happen at? 0.06. So I want you to see I used Desmos to graph my inequalities to get those corners. I needed the coordinates at the corners. Then I take those coordinates and I use it in my z equation to figure out which one's going to be the biggest, or as we'll see in problem number 2, the smallest. Okay, so now I want you to see in problem number 2, the good thing is we used the same inequalities. So our vertices, our corners, are going to stay the same. But our z equation is a little different. And remember, we're trying to minimize now. Okay, so let's take a look at what z would equal. Z would be 3 times 0 plus 6 times 2, that's 12. Okay, now let x be 2, y be 0. So z would be 3 times 2 plus 6 times 0, that's 6. Okay, let z be 3 times 6 plus 6 times 0, that's 18. And then finally, let z be 3 times 0 plus 6 times 6, that's 36. And remember, again, this time we are trying to minimize. And so our minimum value would be 6. Where does that minimum occur? It occurs at 2, 0. So optimization really is about making something bigger or smaller. And it's that z equation we're trying to make big or small. Use your technology, use your Desmos to do your graphing and your shading. And to get those corners, you need the coordinates from those corners. And then you can do your plugging into your z equation to see which one's going to be the biggest and which one's going to be the smallest. Well, friends, I've enjoyed it. It has been a blast. If you've been with me for the entire 8 weeks, you know we've put in a lot of time and effort, but I think it's been well worth it because I think you're understanding the concepts and you're feeling much more confident with all the things that we've been doing. I would heavily encourage you to connect with me on the socials. That way, you continue to get the resources you need to be confident and successfully finish any of your classes. Feel free to reach out if I can help in any way. I would love the opportunity to do that. Bye for now. Thanks for watching.